WebWave Season 2 Tech Talk. The topic is database wars, and our speaker is Syed Ali Razam. How are you, Syed Ali Razam?
I'm fine.
How are you?
I'm really fine, and I feel the audience is really fine, really excited for the Tech Talk. So let's move on. Why database wars?
First of all, databases are very common, like used everywhere from enterprise products to web services, everything. There are many database management systems that are out there, so it's good that we discuss which one is better than the other. There are many conventional databases or relational database engines out there, like from Oracle, the latest 11G, Teradata, version 14, MySQL Server, SQL Server from Microsoft, IBM DB2, Qubit. All of them are there, like relational databases, and all of them have their positives and negatives. So it is good to see how they do and what they are good for, and look at the next level of databases, like where the future is. So like Oracle, everybody knows that it's awesome for transactions. Teradata is good for operational databases, like you need to do transformations and any other thing. Like most of the databases, apart from MySQL and Qubit, are offering data warehousing options among them. So they are offering OLTP, online transaction processing, as well as OLAP features within them. So SQL Server is best compatible with .NET applications that you use. Additionally, it is also good with Windows Server 8, the version that is still in RC. And MySQL is pretty popular. It started basically on its own under the license of Java and Sun, and then Oracle acquired it, the same one which is offering an enterprise database solution. So MySQL is pretty popular in web applications and web servers. It's pretty lightweight and runs pretty awesome. So if you've got, like, say 40,000 transactions a month, it pretty suits you. Other than that, if you have some real operational data, like around say 4 lakh, 10 lakh transactions per month, you would probably look for some high-end databases, for example Oracle, Teradata or SQL Server.
Our university's website, gadget.edu.pk, which the webmasters manage, which database do they use?
They are using MySQL.
They mainly maintain the website pretty awesome.
Thank you. Like IBM DB2 is new in the field, and it still needs to make a strong point, because comparatively Oracle and Teradata solutions are more used in corporate situations. Qubit is a very new database engine that is just come up, and it's specifically optimized for web applications. Like
how specifically?
You can directly query Qubit from JavaScript. Like that hasn't been done recently. All the queries are done through some other language running on the server side. It communicates with the database, manages the data, does some transformation, and then delivers it to the client. But Qubit is pretty new and it's doing awesome, but still it's a relational database. So you might think that our main aim is to discuss all of these databases here, but that's not so. We have got some new competitors.
That will become so boring if we discuss.
Yeah, already online there has been a lot of discussion on these databases that has been done pretty well, but there are some new competitors in the market, some new technologies that we need to see.
So let's know about these competitors.
Okay, first I would like to highlight some points that relational databases like Oracle, Teradata, SQL Server, they don't achieve. Okay, first of all, big data. Now, you might say that relational database support big data, but what kind of big data we are talking about? We are talking about some real big data in petabytes, right? Not even terabytes, petabytes.
That's really big.
Operational cost. Now, you might know that Oracle installation, the requirements, the memory requirements, the disk requirements, the CPU requirements, all of them are much higher than compared to even MySQL. And these operation costs can often be bared if you have your own managed servers. But if you are running a cluster on like commodity cluster or even on cloud, you would like to optimize the cost because you pay for what you use. So if you are using disk space for your DBMS engine, which is not really that important, data is more important, so why pay for it? So that was one thing. Secondly, scalability. Oracle, SQL Server, all of them allow great scalability, but they are not very fast. They require some time to extend to scale. Additionally, you require a specific operating system for them. Like SQL Server doesn't support Linux, and additionally, like Oracle has even compatibility issues. Like 9.9 doesn't run on Windows 7 and Windows Server, the higher Windows Server 8, it won't run. You have to have a latest latest installation. Additionally, especially if you are using it on cloud, like if you are using an instance store image. Instance store is basically an image of an operating system that keeps updating itself from the vendor directly.
Yes.
So additionally there is EBS elastic block storage with permanent storage. So in that cases, suppose that your operating system gets updated. Now what are you going to do? You have forcefully installed some heavy database engine. Now you have to upgrade. So it is a very hectic cost. Modern data types. Well, RDBMS has been having some difficulty coping up with modern data types. Like it has provided support for blob, the big binary, large binary objects, and other stuff like store images and that all. But modern data types are not supported in all DBMS relational DBMS engines on the top class. For example, sending the data in JSON directly, not converting it in an intermediate server-side language, etc. Apart from that, streaming, like it might seem odd, but you can stream from a database server. Streaming videos from a database server, okay, yes. Not stored as files. Graphs. You've seen Facebook?
Yes, sir.
So you've got links with people there. If you think that they are using database management systems like Oracle, SQL Server, or even Teradata, you're wrong, because they don't really support that much graph databases. Okay. Then replication. In cloud and in other, even in commodity servers, there comes a scenario when you have a particular table or some area constantly visiting by your clients. So you want some hotspot protection and prevention features which are not there, like even though there are to some extent, but they require time for application. So that's these are some features which are making the RDMS engines old.
Looking at these requirements, these new functions, I really feel the new generation databases will require quite a lot of effort.
Right. We are going to see some of them, and you will know in detail like what's the difference. First of all, these databases are NoSQL databases. Like by NoSQL, we mean that the normal syntax of SQL is not followed here. These are not relational databases, to be specific. So relational algebra does not apply here. So queries here are usually, for example, this one is using a service context of Azure, and it is basically link written LINQ, language integrated query. So you take a service context and come to some partition like food table, and you query the table as service, like you specify what the partition key is, compare and do stuff like that. So the return of that is an object that you can directly access, not some arrays or something that usual objects like arrays, list, and something like that you have to later convert and work on. So that is a big advantage here.
Yes.
Okay, some NoSQL scalable databases that we are going to discuss here are MongoDB, CouchDB, HBase, and Cassandra. So MongoDB is basically written in C++, and it's pretty efficient. And the main features of MongoDB are that, like many databases, like the relational databases, if you are used to working with relational databases, you would have concept of tables, queries, indexes. It tries to retain most of that concepts so that you don't have to learn anything new. So this is the best thing about MongoDB for the relational database users. Additionally, it is used for dynamic queries like stored procedures. Queries are dynamic. Indexes are same as the indexes used in relational databases. The main thing is big data, and the data, the specific feature that it is optimized for is data that changes very quickly. Consider having 1 terabyte data written every second or updated every second. Consider that. So relational databases don't do pretty well on that. Okay. Next comes CouchDB. It's written in ER language. ER language, do you have an idea? ER language is basically a soft language specifically for real-time applications and scaling them to multiple servers. So it's written in ER language, and it offers DB consistency, ease of use. Okay, by the way, NoSQL scalable databases don't offer asset properties. Asset properties of database: atomicity, consistency, isolation, independency. The reason being that most of them run in-memory databases, right? Because they are more optimized toward performance. So they basically expect that there are no crashes, no system level crashes. So you maintain the operating system and hardware, there are no power failures, sort of things, stuff like that.
Yes.
Because that's pretty important. You can't write back all of the memory data at once at the disk. It is basically good when accumulating data. Like consider you are running an aggregation query on say 10 terabytes of data. So you really need the answer pretty quick. So in scenarios like that, it pretty helps. HBase is basically used with Hadoop framework for the MapReduce. MapReduce is a specific kind of framework for operations. Like you map the task to certain nodes and then reduce the content that they give and extract the information. So it's basically written in Java, so as the Hadoop framework, and it supports only the Java. It is integrated with Java, and it is good for random read-write access. So most of the time you might be reading, you might be writing. It's good for both. Lastly but not the least, Cassandra is also written in Java. It is best for big table and Dynamo. Dynamo is a specific type of database. We might discuss it later. When you write more than you need, like specific operational systems where you are logging sensor data and logging, where you are logging this stuff and not reading it much, Cassandra is the best.
Out of these four, according to you, which database could be the next big thing? Which could lead the next generation databases?
Well, it's pretty vague, and I would justify my comment. You see, MongoDB is basically written in C++ and it's under a different license. But CouchDB, HBase, Cassandra, all of them are licensed under Apache. So Apache is working on all of them. So this is pretty weird. And you still can see the best, what are the best for. So the system architects must decide what their needs are and decide the appropriate database for them.
So if a developer wants to move to NoSQL scalable databases, it will depend on his needs.
Exactly.
Which database he should.
Exactly. These databases are specifically optimized for the specific function you want. Like RDBMS, they are for general use. You might make small applications, you might make big applications. It's relational algebra. You might make different kind of columns, schema, everything else. But these are pretty, I would like to discuss. MongoDB is basically elastic schema, I would call it. Like for example, you have a production server running thousands of queries per day, and you have a specific schema for it. Every 6 months or so, you move that data and archive into archive servers with the same schema. Now think of it like you have to change some schema in the production servers. So how would you map that on tons of data stored in your archive? The transformation would be a hectic job, and that would be very tough.
Yes.
So what MongoDB does is it allows you to have the elastic schema. It basically outputs in JSON, JavaScript object notation. So it's cool, really cool. So you don't have to worry about scaling and progressing. CouchDB is basically also supporting MapReduce like stuff, and all of them are like different. MongoDB, the best thing about I like MongoDB. Do you know any DBMS provider who has provided its driver to be used for its DBMS in every possible language? Oracle has its driver for many .NET, even C, but that C driver is also written by some third party. But Mongo,
Yes.
the MongoDB, they themselves write from starting from C, C++ to even languages that very few people use like Scala. So that's awesome. Like, and even you can query in MongoDB using JavaScript.
That's great.
That's pretty something awesome.
Awesome.
Okay. Here I have discussed only 4 of them. There are 4 more, but that would be too boring to discuss because there are some minor differences between them. These are the major ones that are being used. Okay. There is another one, Windows Azure table. Okay. You might have heard about like SQL Azure.
Yes.
Okay. There's a big difference between SQL Azure and Windows Azure table. SQL Azure is basically SQL Server on Azure. That's it. But Windows Azure table is something big. It's like having a 2-dimensional array, a huge 2-dimensional array, storing every data for Azure. Okay, this might sound some little bit odd. Consider it like having a block of data that belongs to you, and besides it, a block of data that does not belong to you. It belongs to someone else. So it is optimization that the Microsoft people did to store every data in a single table. But the thing is that there were some security concerns also related to that. So they used military grade 128-bit AES encryption so that the data doesn't leak out even in the storage side, even on the network, and it only decrypts based on the key that you have provided. So it's pretty different. Like if you are pretty familiar with relational database, primary keys, foreign keys, and you are pretty good at working in relational database, you are going to have some serious trouble working with here. Okay. So the problem here is that the relational algebra does not apply. You have to learn the things the hard way. Okay. So what happens here is that instead of primary keys and foreign keys, there are partition keys and row keys. And partition key and row key together uniquely identify an object. Now you may have partition like, for example, take food. You may partition food into vegetables, fruits, and any other types. So, and the second partition, the row keys would define what each tuple is having. Right? Now the partitions here and row keys are the basis for optimization here. For example, if I'm running a store selling food and I get too many queries on vegetable, right? It is becoming a hot partition. So what do? I replicate that partition so that there is proper load distribution. Additionally, I can make partitions within partitions. For example, if vegetables are getting huge number of requests, I can divide it into like vegetables that grow above the surface, that grow beneath the surface. And these partitions are providing very elastic sort of architecture compared to relational databases. And there are other optimizations as well. For example, full table scales. Consider having tons of data and you are searching through it. So what it does that you can query only like 1,000 objects at a time, or a 5-second search. What it does that whatever results come in that area are returned immediately, and after that there is a continuation key. So you can have multiple servers having that same query run in a distributed environment. This is something pretty awesome. So consider 1 terabytes of data and distributing which portion to search among the servers that you are having. So that's huge optimization and reduction of hotspots.
It makes it quite quick.
Okay, this one is basically deployed on the Windows Azure service, Cloud Azure service by Microsoft, and the previously discussed ones are open source and you can deploy them. Okay, so one thing that I forgot to mention, Oracle setup is around 2 to 3 GB, right? And even if you install the minimum features, you would consume around 1 GB on your production server. But MongoDB, I just downloaded yesterday, it's just 20 MB. So consider the load. Just 20 MB doing the awesome work.
Thanks.
So many organizations that have huge data to populate and huge like operations to do, they are not using those conventional RDBMS anymore. So it's a pretty new world out here. Okay, so that's the end of here. I would like to show what MongoDB says for itself.
MongoDB lets you develop faster, deploy easier, and scale bigger. Modern applications are more networked, social, and interactive than ever. This is driving new requirements to support big data, fast feature development, and flexible deployment strategies. But is your database ready? Applications are storing more and more data and accessing it at higher and higher rates. If your database runs on a single server, you will reach a scaling limit. MongoDB scales by adding more servers. You can add more capacity whenever you want. Agile development and continuous deployment have accelerated roadmaps. If your data model isn't flexible, it can slow development down. MongoDB increases productivity. Modeling data as documents is simpler and allows schemas to evolve effortlessly without duplication. Cloud computing is changing how we deploy applications both inside and outside the firewall. If your database needs complex hardware, it's not ready for the cloud and can keep you stuck in expensive data centers. MongoDB was designed to work with commodity servers and elastic virtualized environments, saving you money and headaches. MongoDB, it's scalable, agile, and cloud ready. Come see why everybody's scaling out with MongoDB.
Okay, you can see the popular people using it. SAP is using it, and even Bright, server density. Foursquare, I hope you've used it. It generates a lot of data.
Yes.
Every people say where I am, they join, create links. So they are also using MongoDB. Okay, also the best thing about MongoDB is that it is operating system independent. So let's say you have a cluster of 5 Windows server using MongoDB, and additionally you get some 3 to 4 Linux servers. So it performs exceptionally well on heterogeneous environments as well. There's complete compatibility with different kind of operating systems. Here's what Amazon DynamoDB says.
When you're building an application, you want it to run fast, and you want it to stay fast as your business grows and more people use your app. Databases have always been one of the biggest challenges in scaling these applications. Most databases just weren't designed to match the scale and performance needs of modern apps. As more and more people use your app, and you add more and more web servers, the database layer often can't keep up. It gets slower and slower and sometimes fails, taking your application down with it. You can try to get around this problem by building a large cluster of databases. This can work for a while, but it's hard and expensive and requires a lot of expertise. You have to make sure your database keeps running and data isn't lost, even if one of your servers goes down or there's a problem with one of your data centers. You have to know what to do if your application grows so fast that your cluster is no longer big enough. And you have to make sure your databases are running the latest software and be ready to patch or upgrade the software without shutting down your business. What if you can replace all this complex software and hardware with a database service designed from the
Okay, so I would like to emphasize on a special point. Like most of you must be thinking that we have a new database system here. So relational databases are over, and like what do we do? But the thing is not like that. These kind of databases are specifically designed for big data. So relational databases are still not up. And additionally, for students here, I would like to say that don't get into this before clearing out your database course, because you are going to have some tough time, like managing the non-SQL databases, learning about them, and then shifting to relational databases. The relational databases are important nevertheless.
So, any questions by the audience? I can see Usama Nadeem has a question.
Come on, ask questions. No? Okay. So, do you have any question?
No. That was a pretty informative TED talk we had, and I would really like to thank you for giving us this TED talk.
It was my pleasure.
So, we'll end this session on Database Wars, and we'll meet soon for the Season 2 Bot Wars workshop real soon. Thank you.